So yeah,
Project
let us
identification tool.
select the topics and then we'll proceed accordingly. Okay. So today it's going to be understanding project identification tools and SIPOC. Because already we have completed define phase. Do you all remember? Define phase is completed, right? In the second week, yes, I only took the define phase. We have learnt about the project charter. We have learnt about the Pareto. Do you remember all of you, or you have forgotten completely?
No, sir. Correct.
No, sir.
Remember.
Yes, sir,
Remember.
remember.
This
Remembering,
one.
right? Very good. So now we are going to add, some further understanding, and particularly I'm going to speak to you on these lines. How to identify projects? Are there any tools available, or any, methods available for project identification? And then SIPOC,
Mhm.
supplier, input, process, output, and customer. Then we'll move to gauge R&R study. And then we will also talk about process capability analysis, right? So these are the topics for the day. We'll take a short break in between around 8:30. So remind me. So tell me, how can all of us identify projects? As a green belt, if you want to do a project, if your company is, proactively identifying projects, then it's a different scenario. They will come up with hundreds of project ideas, and then all the projects will be prioritized, meaning they will be, arranged in a proper order. Now the everything is, carried out by the top management. Everything is carried out by the top managements, and then teams will be equipped. I mean, the necessary training will be provided, and then projects will be the projects which are suitable for Six Sigma methodology will be separated, and those projects will be allocated to the skilled team members, who can lead the projects. That is how, the things will happen. But in case if you have to identify the project, if somebody is doing, if there is a committee and who will identify project and allocate
Uh,
projects, then your job is very simple. You just have to lead the project and manage the team and do it. But if suppose you have to identify the tools,
Sir, 80/20.
80/20, yes, it's a technique we use, or no, the prioritization, a kind of prioritization where you can identify the top 20% of the problems, considering the whole lot of problems. Yes, yes, Pareto can be used. But if you ask me the project identification, one source is customer complaints. Do you all agree?
Yes,
Yes,
sir.
sir.
Customer complaints are nothing but the direct signals of quality failures, right? Coming from your customers, external customers. That means there are field failures, and there are some, yes, non-conformity reported by your customers. Let's say there is a failure of, yeah, your coolant pump, or failure of, some engine component, whatever. If that is reported, then you may have to immediately investigate why such components are failing in the field. Is there any no capability of our system in line with such failure need to be improved. In that sense, we have to identify a project, right? So one source is customer complaints. And I hope all of you know there are external customers, there are also internal customers, right? So
Yes.
external customers, or the complaints coming from external source, or the failures identified outside the organization are known as external failure, are known as external failures.
National
And
Film.
the cost associated is known as, failure cost, failure cost, or external failure cost. And if the failure is identified internally, let's say there are internal rejections, there are internal, delays, or internally, there are certain rework happening. These kind of things are, again, contributing to the cost of poor quality, but these are called internal failure cost. These are called internal failure cost. So you can identify projects from the customer complaints, basically. Maybe from external customers, also from internal customers. Are you with me on this? But in both cases, it's a case of failure. Every failure comes with a cost. Agree with me, all of you? Every failure comes with a cost, and
Yes, sir.
so
Yes, sir.
the cost associated with failures are normally called as cost of poor quality. There is external failure cost, there is internal failure cost, and certainly you can execute. You can actually consider that as a project, and you can solve that problem. Okay. So the best normally in industries, a methodology called 8D is preferred, particularly when customer complaints are reported. When customers are reporting a complaint, the methodology normally in practice in the industry is what is the methodology I told you? 8D, 8 disciplines. If you would like to know about the 8D methodology, you can consider joining our certified root cause analyst program. The next batch is in June. There we will talk about 8D, A3, and the QC story kind of methods. But here we are talking about DMAC. But definitely customer complaints can be handled using DMAC methodology also, because DMAC methodology is capable enough to handle even customer complaints. Okay. And another way you can identify project is KPI gap.
Sir, I have
What is
one
another?
question.
Yes.
If the DMAC is capable for everything, every root cause analysis, why we have different kind of tools like a 8D and all? Why not only one?
Hmm. Good question. Because many methodology exist already. Before we were born, the methodologies were created by different companies. And initially they had the simple methodologies like PDCA, Plan, Do, Check, Act, isn't it?
Yes, sir.
Then people realized it's not robust enough. And so other methodologies were also introduced. It's a continuous improvement, we say, isn't it? Tomorrow there can be 10 other methodologies which will be introduced. We don't know. And if they are found to be helpful, then they will also appear in the syllabus. Okay. So different
I got it.
methodology we follow because they exist. And so companies have the freedom to choose any methodology they want. There is no strict regulatory guideline that you should follow only this methodology. But 8D, yes, 8D is recommended by AIAG. So if you are in automotive domain, probably you will be expected to follow 8D methodology for all customer complaints. Are you getting
Okay.
my point?
Yes, sir.
If your company has a policy of solving all the problems only using A3 template, then in your company A3 methodology is required because they are following, isn't it?
I am.
So in the currently in one of the company I'm dealing with right now, they prefer a QC story methodology.
7
They prefer story methodology because they are more familiar. Their people are more familiar with what QC story methodology, and so they are following that. But every method, there are certain limitations also we need to understand. But definitely, when you use the DMAC methodology, so it is definitely in line or even little above the methodologies such as QC story or AD. It is on par or even above those things. So definitely no, the DMAC is on the higher side, which means you can use it for solving problems of any level of complexity. Even problems with the higher level of complexity can be dealt using
Okay.
DMAC methodology. Okay.
So basically, the every methodology theme is only solving the problem.
Yes, everything, it's only solving the problem. If the problem is highly complex, data intensive, and then DMAC is the best choice.
Okay.
If you're in an automotive industry and if there is a customer complaint and solution has to be delivered and the corrective action must be taken in the shortest possible time, then 8D methodology is the prescribed one. Okay.
Okay, sir.
But
Got it.
if you are in a company that believes in a standard template for problem solving, then A3, standardizing your project reports and the the presenting your project work to the management. If the management expects standardized templates, normally companies go for A3 because A3, the printout will be a little bigger than your A4 and easy for your management to understand and also easy for the team to accommodate the entire information, isn't it? And it is a single sheet. The whole project is presented and it is introduced by Toyota.
Keep there.
Right? Yeah, that's the thing. And then there is something called QC story.
7 QC2 QB.
QC story. It's a Japanese method, and that will also have 7 or 8 steps. The first step is problem, second step is observation, the third step is analyze. So we'll not deep dive into those things, but QC story, where the idea is, to enable the entire project activity get presented in the form of a kind of storytelling. So the project team also finds it interesting. The audience will also be able to understand if the particular sequence is maintained. So which is called the QC story methodology. And for simple projects where what do you call cyclic improvements is the target. If your improvement is you want the improvement to be cyclic, in the sense I want to quickly implement, see the result, and continue improving the results. If that is your ideology, then you can follow PDCA: plan, do, check, act. Okay. So different methodologies exist, but Six Sigma bells normally use what? The DMAC methodology. And I was talking about the project identification. One is external failure, customer complaints. Another thing is internal failure, internal complaints. But in both cases, it's a failure. So both of them fall under failure cost. The cost associated with failures are normally called as cost of poor quality. But there are efforts required to prevent all these failures. Am I right? Your company might have taken, those efforts already, like QMS system, following a QMS system, and creating SOPs, isn't it? And reviewing the design, finalizing the design, doing inspection, doing internal audit. These are activities we do to proactively prevent all these expected failures, isn't it? The internal failure and external failure can be prevented if we are too good at, let's say, inspection and auditing, calibration, and all those things. If you do it, very systematically at appropriate frequency, automatically all these failures will start going down. Am I right or not? Are you getting my point, all of you? If you want to
Yes,
remain
sir.
reactive, if you want to fix the problem after the
Sir,
customers,
understood.
yeah, if the customers have raised the complaint and you solve it, it's a reactive way of, problem solving. But you can also solve problems proactively. You can be, you can actually try to understand the failure possibilities and you can try to fix the, prevent the failures, by improvising your design and the process. And those kind of activities also consumes resources and so there is a cost associated, right? And if you focus more on inspection, appraisal, audit, then these are called appraisals. Are you getting my point? Inspection is happening every day. Some audits are happening at some predefined frequency and equipments are getting calibrated. These are all called appraisals. The cost associated with these kind of appraisal activities are called as appraisal cost. And tell me, how can I categorize this cost? Can I categorize this as poor quality or a good quality?
Poor
Good
quality.
quality. Good quality.
Good quality.
Good quality.
Yes. Doing inspection,
Quality,
doing
good
appraisal,
quality.
conducting audits. These are
Good.
all, the intention is to prevent the failure. Otherwise, so many failures will start happening internally as well as externally. Yes or no? Just imagine
Yes.
Yes.
you eliminate all your inspection, auditing, and calibration kind of activities. Then see what happens after 1 month time. You will see your customer complaints and internal failures, internal rejections, and everything going up. So this is actually classified as a cost of good quality only, called as appraisal cost. Called as appraisal cost. To minimize on the appraisal, what are we supposed to do? But appraisal doesn't actually adds up to your quality. Appraisal only detects if there are any compromise in the quality happens. Am I right? So you have to do some other task proactively to ensure there are no quality gaps, there are no quality compromises, you know, in our work, and so the appraisal task will only be able to find only minimum of failure, minimum of gaps. So all those activities that proactively ensures the assured quality is delivered to the customer. The assured quality is known as built-in quality. You might have heard about the term, right? Built-in quality. What is built-in quality? The quality that is planned to be delivered to the customer. That is called built-in quality. So to ensure the built-in quality is delivered to the customer without any compromises, we will be doing a lot of activities which are known as prevention cost. The activities are called prevention activities, and hence the cost involved is called prevention cost. How many cost elements I have identified? I have explained this right now. There is
Cost of
external
good
failure.
quality, cost of bad
Appraisal
quality, and
cost.
Very good. Cost
prevention
of poor
cost.
quality, cost of good quality. And good
Hmm.
quality, there are two types, and poor quality, there are two types. What are the category of cost under good quality? Prevention cost,
Prevention
Appraisal
cost.
cost.
appraisal
Appraisal.
cost.
Appraisal cost.
Then poor quality, there are two kinds of cost. One is internal failure cost, another one is external failure.
External failure.
External
External
failure.
cost.
External.
Remember the words prevention, appraisal, and then failure cost, right? Now all of you are undergoing this training program. Some
Okay.
resources are getting consumed, isn't it? You have invested some money, you have invested some time, you are putting some efforts. And what do you think? All this investment and time, effort, and everything should be categorized
Good.
as
Good.
Good
Cost of
Quality.
good
quality.
quality.
Good.
Cost of good
Good.
quality.
Good
good
quality.
Good
quality.
quality.
Within good quality, there are two things. One is prevention, another one is
Appraisal
appraisal.
cost.
And what is this? Training your
Appraisal cost.
employees.
Appraisal
Training.
cost.
Training to prevention. Sir.
Training
Prevention.
your employees is a prevention activity. But appraisal means,
Prevention.
yes, already we
And
told,
implementation.
inspection, auditing, some kind of appraisal related task. But then normally, equipping your team or people with the necessary skills is a kind of prevention. All right. So, and your QC checking and ensuring that all the measuring instruments are remain calibrated, getting calibration certificates, all these things comes under
Prevention
Good
cost.
Prevention.
quality. Guys.
Prevention.
Good quality. Prevention.
appraisal.
Prevention. Appraisal
Appraisal.
cost.
Appraisal. See, it's only a terminology, it's only a categorization. So understand, and then you also categorize the same manner. We are spending money. Yeah, all of them are our we are putting our money. We are spending our money, but under certain head we can categorize. One is cost of prevention, another one is cost of appraisal. Then there is cost of failure, which can again be divided into internal failure and external failure. There is a relationship between your cost of prevention, appraisal, and failure. Normally, the what do you call the rule is 1 10 100 rule. It is called 1 10 100 rule, which means if you spend 1 rupee in prevention, you will be able to save 10 rupee in appraisal. That means, say for example, I am focusing on at maintaining a CPK of 1.67 and above. You know what is CPK? Process Capability Index. I want to run my process at a higher level of capability, right? See, when you are writing an exam, what is the pass mark? All of you, do you know the pass mark for the exam?
60%.
60%. But do you just want to score that pass mark, or do you want to score very high, 95
No,
plus?
sir. No, sir.
Very.
Near 95.
Yeah, nobody want to merely pass the exam. They want to score very high. Similarly, process capability can be built just to deliver, the customer requirement, or you can also build the capability to a much higher level and deliver premium products to your customers. Offer premium services to your customer. If you are interested in just meeting the customer requirement, then a CPK of 1 will do. We are going to talk about CPK today after this, right? So CPK of 1 means you are just trying to meet your customer requirement. But CPK of 2 means you are trying to
Exceed.
deliver, exceed the customer requirements, delight the customers. You are trying to deliver premium products, premium services, premium quality products to your customer. That means CPK of 2. CPK of 2 means the process is operating at Six Sigma capability. So CPK of 2.
Sir, there is one question. The infrastructure of a factory is coming under preventive cost because total infrastructure is for.
Yes.
Please clear.
Infrastructure, machineries, your people. See, the bare minimum, all of them requirements are preventive only.
Okay.
Because if you don't have that, definitely, let's say 10 machines and you don't have operator for certain machines, and definitely it will trigger failure. So
Correct.
preventive cost needed, the needed resources have to be provided, right? So they are all of them come under prevention only. Good. We are talking about CPK. So CPK of 2 refers to Six Sigma capability. And so see, when you talk in terms of process capability and work towards a CPK of 2 or CPK of 1.67, these are all actually coming under preventive cost. Isn't it? You are trying to prevent the failure. For that, you are building your process to run at a higher capability. So the 1 10 100 rupee, spending 1 rupee can save 10 rupee in appraisal. How? If a process capability CPK is very high, 1.67 and above, then it requires only little inspection. Is it logically correct?
Right, sir.
Yes.
Correct.
Yes. Right, sir. Right.
Process is operating at a higher capability, so I don't have to do the inspection. 100% inspection is not required. Just some sampling inspection is enough, and that too at a very manageable frequency, manageable sample number is enough. So that means putting 1 rupee in prevention is helping to save 10 rupee in appraisal,
Appraisal cost.
or and additionally, it will also save 100 rupee in my failure. If you don't understand this relationship, if I don't put that 1 rupee, I may lose 10 rupee in the appraisal, and hence, I have to do a lot of appraisal activities, and there will be corrections happening, and obviously there will be too many failures as well. Correct? So, not spending that 1 rupee needed on the prevention will lead to a loss of 110 rupee. Right?
Yes.
10 rupee appraisal, 10 rupee in the appraisal, and another 100 rupee in the failure. So the moment you understand certain activities related to preventive nature, don't hesitate to spend that. and spending wisely in the prevention and appraisal can drastically eliminate failures, right? This is called cost alignment, and we should be doing it. And you can also identify, certain projects based on the COPQ analysis. What is COPQ analysis? Cost of poor quality analysis. If you have a record of cost of poor quality associated, process level, product level, you can actually visualize all of them and find out where the cost of poor quality is very high and pick up the process associated with it. And that can now be a candidate for your improvement. Are you with me on this idea? Yes or no? This is called COPQ analysis, right? What analysis? COPQ analysis. And the KPI gap. What is KPI gap? What is KPI?
Target
Key
KPI versus
performance
indicator.
indicator.
Key
Yeah,
performance indicator.
key performance indicator.
Correct. Key performance indicator.
one question.
And it's nothing but a number, but that number will help us to understand whether we are progressing towards the target associated with the goal or not. Am I correct? KPI is a number that helps us to understand whether we are progressing towards the target associated with the goal. Because a goal without a target is meaningless. Isn't it? We have to have a numerical target, right? Because the measurable problems, yes, they can be easily solved. So measurability is important. Yes, Ajay.
Sir, one little doubt I have. This 1 rupees prevention cost can avoid 10 rupees of appraisal cost, right, sir? What this
Yes.
rule is saying, and 10, this is 100 rupees in failure cost. So if he says 1 rupees, we are spending one, if we are not spending 1 rupees, there may be cost to company 100 rupees, not 110 rupees. Is it correct, sir?
See, correct. See, 110 100 rule says, yeah, 1 rupee. If you avoid, spending in a preventive activity, then because of that, automatically, you have to do a lot of what do you
10
call
times
checking and all those things. You will rely on, too much of appraisal.
inspection.
So cost
Yeah.
will also go up. And even if you do 100% inspection, you will not be able to, eliminate because the
Correct.
problem, the root is at some other place. So merely detecting the problem is not the solution. So problem will continue happening. So failure will also be happening. It's only a thumb rule. It's only a thumb rule, and out of
Okay.
experience, people have found that, and you can
Right.
easily remember that. And you can just by following this principle, you will be able to spend wisely, right?
Right.
That's the
Right.
idea.
Thank you, sir. Thank
Understood. So, yeah,
you. KPI
the
we are
CO,
discussing.
the COPQ analysis. And we are talking about KPI, right? Key performance indicator. So these are nothing but numbers which will help us to understand whether we are progressing or not. They're also helping us to understand whether we are progressing towards the target or not,
Right.
right? Will help us to understand whether we are progressing at the right speed or not. Okay. So only those kind of numbers should be called as KPI. If you are not able to answer all my points or any of my points, then it shouldn't be called as a KPI. It should be called as a metric only, right? And KPIs, targets are already made available. Please understand. KPI means targets are already made available and the target is associated with a goal. There are operational
Right.
goals. For the downline teams, operational goals are available, isn't it? And at the department level, annual goals are available. And the top management will be working on strategic goals, some bigger goals. And the KPIs must be interlinked. KPIs must be interlinked in a way that the various departments will work in support with the other departments. If I have to attain my KPI, then I have to work, in a very cooperative way with the other department. Then only I will be able to attain my KPI. This is how the KPI must be interlinked. Okay, goal alignment is very important, but these are responsibilities of top management. But at the operational level, the operational KPIs with respect to quality, with respect to productivity, with respect to delivery, with respect to cost, with respect to safety, and with respect to people's morale. There are KPIs available, yes or no? Tell me
Yes.
what is the KPI I can look at to understand whether my people are motivated or not. Your employees' morale is very important.
Facility and accommodation salaries.
No, not kidding. So one KPI to understand the morale in your organization, whether your people are motivated to work in the workplace, motivated to work in the,
Attendance, sir.
so you
Attendance.
can look at
That's one of the
you will check
KPI.
attendance, right?
Yes.
People are not interested in using poor attendance. Okay, good.
Kaizen
But that is
submission. Kaizen submission.
in submission, good. And some companies they explicitly measure their motivation level. They even call it an employee motivation score.
Efficiency achievement.
Like customer satisfaction score, you can also have your employee satisfaction score or employee motivation score,
Yeah.
and you can have a formula behind, and you need to conduct that survey
Survey, sir.
periodically.
Yeah. Yes, a survey is common.
So, so these are efforts put in to understand the moral level, and we are trying to make everything measurable. If measurability is made possible, then we can certainly improve. Wherever measurability is not made possible, there is everything is very vague, and people really
Right.
don't use data. In those areas your improvements cannot be sustained. Sometimes improvement may not be possible, and even if you improve, you will not be able to sustain it. All right, so another area you can use for project identification is look at your operational KPIs and see where and all you are lagging. Let's say a certain process, as per the document, the CPK should be, process capability should be, 1.67. But the actual CPK is, 1.2 only. And that can be taken up as a project. Are you with me, all of you? Do you understand? This is
Yes.
KPI. Ultimately, whatever way you understand a problem, very important thing you all must do is make the problem measurable.
Yes.
Let us say you all feel like your what do you call your
In-
obesity is your problem. Your
Reduction of
overweight is
customer complaint.
no. I'm just talking a simple example. Let's say you suddenly understand you are overweight. Your body weight is more than the ideal weight. This is the problem. Now, if you really wanted to fix this problem, the first thing you should be doing is you should be able to measure your body weight accurately. You see such people immediately buying a weighing machine. Yes or no? Because somebody told you that the excess weight in your body is the root cause for many big diseases. Since you are put in extra 20 kgs, and that is what is attracting diseases every month. The moment you realize and you would like to stay at an ideal weight, then the first thing you will be doing is what? You will buy
Like
a
weighing,
weighing machine.
weighing machine.
Yeah. So measurability is the key. Measurability is the key. So if you want to do a project, and most important thing is you have to immediately after identifying the project and see whether you can measure the problem. For measuring the problem, you need a metric. The metric can be a KPI. You can start with the KPI, no problem. You can start with the KPI, but you have to drill down the KPI and bring it closer to the process level KPI. Do you get my point? Let us say one important KPI is customer complaints must be zero. Yes or no? No company would like to have customer complaint coming every month. So what is their target?
Zero.
Customer complaint is zero. But
Zero.
right now every month 3 or 4 complaints are coming. If you look at the graph, every month 3 4 complaints. Now the project goal is to reduce the customer complaints to zero. Is it a good goal, all of you?
Yes, sir.
Yes, sir.
My question, but my question to all of you is it a problem or a symptom?
System.
Customer complaint,
Problem, sir.
It's a
Problem.
symptom, sir.
customer complaint, should I classify as a problem or should I call it as a symptom?
Symptom, sir.
Symptom,
Sir.
because something is wrong. Because it is getting escalated to the next level of customer raising a complaint, yes or no?
Right.
Yes.
Problem is not customer complaints. That is correct only. Customers are complaining because they have found a non-conformity. If you want to fix that fix the customer complaint, you must fix the non-conformity. That is that particular failure you must arrest. Yes or no?
Yeah.
Yes, sir.
Your understanding on the problem is very, very important. Most of the time, people don't attack the problem because they simply stay and talk around the symptoms only. So when your project goal is to reduce the customer complaints, you have to do a drill down exercise. Do a drill down exercise. Customer 4 complaints have come. Why? Because there is a field failure. And what kind of failure it is?
Yes,
And
sir.
then there is a spring got disconnected. Why it got disconnected? It was not tested, right? Or if it was not tested, if it is tested, then the strength, the designed strength is not sufficient. So now we have to increase its a kind of the strength of this spring, and so we have to actually find out the process that is responsible for the particular failure. Are you getting it, all of you?
Root cause, sir.
Merely, what do you call? The understanding the customer language is not enough, right? Customer language will certainly will be very vague, and the measurability will be very poor, isn't it? You have to drill down. You have to drill down the customer voice and convert them into measurable metrics and make sure the metric is brought down to the process level. Are you getting my point? The CPK of a particular process is very, very low. And because of that only this failure happened. When you could talk like this, your project is identified. Otherwise, you can max to max, what you can do is you can only do a temporary solution to the problem. What do we call it? Problem containment. If you do not do this, max to max, what you can do is you can do a problem containment. What is problem containment? You ensure the problem doesn't spread further. If a spring is getting damaged, what will you do immediately? You will do 100% inspection of the spring. Yes or no? That's a containment. You have still not understood the problem. You have still not fixed the problem. But what you did, you have taken a containment action, like Corona period. The first thing we did, all of us, we started wearing masks, isn't it? We started washing our hands. These are containment actions, not the solutions, isn't it?
Right.
We continue to stay in-house only. These are only containment action. And then we have actually come out with a real corrective action. So in order for you to enable the real corrective action, the problem understanding and measurability of the problem is very, very important. So you have to drill down till you reach the process. Are you getting my point? You have to drill down. See, customer is complaining from Gurgaon, but your factory is in Bangalore. Isn't it? If customer is complaining from Gurgaon, you can't do anything at Gurgaon, isn't it? What is that complaint about? What is the product it is? What is the kind of defect customer is worried about? And customer language, can it be in technical terms?
No, sir.
It cannot
No.
be.
It can be.
And
Can be not. Mostly not possible, sir.
Yeah, mostly not possible, maybe or may not be. So it is our responsibility to convert the language into a technical language and then see what exactly has gone wrong, what kind of non-conformance it is, and also find out what is the specific process. Process level you have to drill down. First, you drill down at the component level, part level, and then find out the specific defect and then relate it to the process. Once you could relate it to the process, yes, you identified the problem. There is something wrong with the process. What I am trying to say is the origination point of the failure must be detected. Origination, defect origination. What is that? Defect origination. Defect will originate from a process only, yes or no?
Correct.
It can be
I
Yes,
assembly,
sir.
it can be associated with assembly, or it can be associated with the manufacturing, or it can be a production, or it can be associated with packaging. We don't know. And this
Qualification.
is called defect origination. And after the defect is originated, that is triggered, at which point within the line it is getting detected. Are you getting my point? Defect is getting triggered at one point and it is getting detected at some other point. All the process steps, all the process that we carry out between these 2 points should be included in the scope of your project.
Yes.
Okay.
Are you getting my point? Very, very important. The
Yes,
defect
sir.
is
So
triggered at some point and it is detected at some other point. Let us say a hotel, is daily, they are manufacturing breakfast for 5,000 people. And there is a complaint that, the idli is very hard. The idli is very hard. And they make so many products, not only idli. They also make dosa, they also make pongal, they also make vada. And complaints are not about vada and dosa and pongal. Complaints are about what?
Idli.
Only
Only,
idli.
Very hard.
only.
Only.
Now, will you be able to go to the idli making line, the line where the idli is produced? Yes or no?
yes, very good.
There are series of machines, arranged. It's a big hotel or a big restaurant, 5,000 people, imagine. So they have a big facility where one line is dedicated for idli only. What is the problem?
Hard.
Very hard.
It is very hard. It is not soft. And it happens, it's a recurring problem. That's another thing. It's not just one idli which is hard. Then we can easily throw it out. Almost, it is occurring, repeatedly. So analysis and fixing, root cause fixing is important. Now we need to find out the origination point of the defect. Tell me what could be the origination point? Is it only the steaming process that needs to be investigated? Or is
No,
it
sir.
Mixing
Raw
the flow.
materials.
First
No,
we
no, no.
first we checking
Raw,
the
raw material mixing may be the point.
Fermentation, mixture,
Ah,
raw
Baking
material
soda,
first
checking.
we
baking soda, baking
Raw
soda,
material
not
mixing.
very
Raw
good.
material may be,
So you want to start from the fermentation, isn't it?
yes, sir.
And then somebody, loads your idli steamer. Maybe there also you need to investigate. And then the steaming is happening. And then somebody is actually, like what do you call is, what do you call?
Evaluating.
Yeah, he is just checking whether the steaming is proper. And then she will be, he or she will be separating the idlis and then for delivery. So the starting point and end point has to be identified. Correct? And
yes.
you also need a metric now. See, you need another metric now. He started with customer complaint. All of you, please remember. Zero customer complaint is the KPI. There is a problem with the KPI. And that KPI is now drilled down to a problem in a idli making line. Now in the idli making line, I need another metric. This metric should now be called as project Y. This metric should now be called as project Y. You can also call it a pain metric. You can also call it a pain metric. Now tell me for the idli case, what kind of metric can help you to understand the intensity of the problem?
Ratio.
Mixing ratio of
Ratio of
rice and dal.
number of idlis rejected against number of idlis produced. Yes or no?
Yes, sir.
Ratio of
Yield.
number of idlis rejected against total produced.
Number of
If
Total
you find
produced.
it, or if you find it, no, it is not a good representative, then you can literally check the hardness level of the idli, isn't it? The problem is with the hardness of the idli, people not finding it softer. The more harder it is, and less softer it will be. Yes or no? We want it to be more softer, so hardness should be below a particular level. Now you have to find a way to measure the hardness of the idli. In hotels, they take a toothpick and then insert it, against an idli. Have you seen? They
Yeah.
take
Yes, sir.
what are they trying to do? They are trying to understand, whether the idli is harder, softer, whether it is properly steamed or not. Am I right? But when it comes to a Six Sigma project, toothpick method and all, will not is not sufficient. You should actually have a hardness tester. Like you purchased a weighing machine for yourself, you must have a hardness tester and measure the hardness of the products, isn't it? Are
Yes,
you
sir.
following me?
Yes.
Yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes.
Agree.
Understand.
If you don't think to this level of depth, Six Sigma methodology is not required. You can continue solving problems at the surface level. Are you getting it? So in Six Sigma methodology, our objective is to identify problems which are recurring in nature, problems which are complex in nature, meaning identification of the root cause requires an analysis with intense usage of data.
Sir, I have one doubt.
Yes.
If the customer complaints will come, that means we escaped inspection from our side. Is that right?
It can be. It can be.
So first we should check the how it escapes prevention, escapes root cause analysis, or should we first contain the problem to identify the root cause of the product?
See, containment is always required. Problem
Knockout.
containment is always required. The moment you notice a problem, the first thing you should do is contain it. Make sure it doesn't spread further. Make sure the already affected parts do not progress to the next stages. Yes or no? Otherwise, the downstream process will start consuming a defective, component. And what is the point of processing a defective component? Isn't it? Anyway, it is going to be defective. So containment is very important. To ensure the containment is done properly, you can actually increase the what do you call the inspection. You can even plan for 100% inspection, but 100% inspection is not the solution.
So
Is not a solution,
escaping
but definitely it
from
can
the
definitely
inspection
it
is the
can
one
be
of
a
the problem.
it's a kind of containment approach. You can you are not necessarily 100%. You need to increase your sample size. I mean, increase your inspection rate to make sure the defective item doesn't progress further. You can also do rework, isn't it? And again, that is a containment action. All the defective parts before proceeding to the next stage, it will be corrected there itself. Again, it's a
Equivalent.
yeah. So there is a containment action and also there is a permanent solution. So what my point here is why am I explaining all these things in a deeper way is I want all of you to think in the same way while identifying a project. Your skill sets are required only for such a level of candidate, and at the same time, you are identifying the process and understanding the scope, and you have to identify the project why correctly. In the idli example, we finally drill down to hardness of the idli, and if the hardness tester is not available, we may not be able to fix the problem effectively. isn't it? We'll not be able to validate, isn't it? We can still say we have taken some action, and that is okay with idli process. But with your factory, with the kind of product you deal, you cannot give approximate solutions to your customer. There must be an evidence of no effectiveness of the solution.
Uh,
Yes or no?
Still,
You're not.
sorry, sir. The harness tester is still a control method, not a root cause.
No, no. Hardness tester is required to first validate the problem. Yes, hardness is not sufficient. Yes, this is why has finally led to a customer complaint. So what is the current hardness? What is the required hardness? A gap exists or not? If a gap exists, problem is validated. Yes, problem presence is confirmed. Yes or no? Know why the
Uh,
hardness drop, whether people follow the procedure or not. If people follow the procedure, is that all the what do you call optimum values of the process parameters are followed or not? Settings are correct or not? And that itself can throw light on the root cause, isn't it? But if everything is found to be followed and all the X factors are also found to be, as per the standards, still problem happens, then a systematic root cause analysis is required. But problem is validated. So my point here is project why and yeah, proper definition for your why. Proper definition for your why.
got
When
it,
you
sir.
say hardness, yes, how to measure the hardness? What is hardness and how to measure it? When you say the problem with surface finish, how to measure the surface finish? When you say problem with the thickness and how to measure the thickness? And do you have a measuring instrument to measure the thickness? So measurability is very, very important. When you say employee motivation score, you should know how to measure the employee motivation score. If no method exists for measuring the employee motivation score, and you doing a project there and then improving the employee motivation, there is no like we cannot guarantee using the methodology. Are you getting my point? So every problem, every voice of the customer must be drilled down to a measurable metric. If it is a customer voice, the drill down metric will now be called as CTQ. What is CTQ? Critical to quality.
Critical to quality.
Critical to quality. If the problem is not raised by the external customer, it is raised internally or raised, by your management. And particularly if it is management voice, then we call it CTB, critical to business.
Listen that.
Let us say your inventory level is the problem. You keep too much inventory for a particular product and you want to reduce the inventory or you want to reduce your procurement lead time for a particular part. Always the part is not available for the production. So production is getting delayed. Now procurement lead time is the problem. And this metric is now called maybe CTB, critical to business. Are you getting my point? And your rework rate, that is again, CTB. These are no problems of your management because the people, if they do more rework, then it will add up to the more cost, isn't it? So you can identify project and you need to drill down and find out the measurable metric, understand the scope, and with all these things, yes, you can certainly write a project charter, develop a project charter. And already we have taught you project charter. All of you, have you, I think, I don't know whether I have suggested you to prepare a charter or not.
Yes, sir. You have informed us.
Yes, sir.
Yeah, please do try to prepare a project charter, which must be, sharp enough to narrate the problem. Don't be, writing something at the surface level. I don't like it. You have to write the exact problem at the process level. And these are the real candidate for root cause analysis, real candidate for DMAC methodology. Otherwise, like one of our participant was asking, it can be handled by some other methods. Okay, done. So scope is clear and all those things are clear. And one other source you can rely on for project identification is audit findings. What is that? Audit findings. A recent audit conducted And there are many areas, some gap is found and non-conformances were reported, major non-conformance, minor non-conformance, isn't it? And all those suggestions can also be a good source of project identification, right? But in your case, as a green belt, as a black belt, your requirement is how many projects? Tell me, all of you. How many projects do you have to identify?
For black belt, 5 to 6.
Then you're gonna do your regular work. One project is enough. If you are driving, project
At least
yourself,
one per year.
one project is enough. You are not, see, by definition of a black belt, yes, you have to do 6 projects.
Yes, yes. For black belt.
Company has not yet appointed you as a black belt, isn't it? They have appointed you with some other designation. Now you are not a full-time black belt. But this project, you are doing it, by identifying a project yourself. And so one project is enough, right? But if your company expect you to work as a full-time black belt, then you have to do 6 projects in a year. And your compensation will definitely be beyond imagination, beyond your expectation. And you can deliver a huge savings to the company, project by project, several lakhs, sometimes close to crores, sometimes more than a crore. Single project can deliver, and you need to quantify and all those things. This savings of lakhs and crores. At which component of the project charter you will be including the financial savings? Can one of you answer this question? Which component or which element of the project charter will talk about the financial savings?
Director.
Measure. Measure.
Yes, sir.
Business
Yes,
case.
sir.
Business case. Very good. Very good. Good understanding, right? And always when you talk about business case, financial benefit, you have to indicate the annual savings, right? If it is a cost of poor quality, annual cost of poor quality. 1 year time, what will be the cost of poor quality or what will be the potential savings? You can highlight. Okay, very important. And just now I told you measurability important and pain metric identification is important, definition is important, a formula is important, a unit of measurement is important. Hope you have noticed all those things. If you say hardness, you have to write a definition for hardness. You have to write an instruction on how to measure hardness. You should also write a definition, include the unit of measurement as well. I think one participant put something in the chat box, Bharat Kumar, Brinell tester or the Rockwell hardness tester.
Yes,
So
yes.
this will some kind of number, Brinell hardness number or Rockwell hardness number. It's a kind of metric which will talk about what? The hardness of your material, isn't it? And there is a clear, well-defined target available, and your measured value is also known. Now the gap is the problem, right? So the pain metric, where should you compulsorily include the pain metric? Can one of you answer this question? Which element of the project charter should talk about the pain metric? We call it project Y or pain metric. Pain metric should always be specific and measurable. Which element of the charter should talk about pain metric? Is it business case? Is it problem
Analysis.
statement?
Problem
Or is it
statement.
problem statement? Yes, very important. Problem statement should talk about the pain metric. You must explicitly declare the current state of the pain metric. When you say hardness, what is the current hardness? You should declare. When you say rejection, what is the current rejection? You have to declare. What all of you do you understand? Current state. The problem in its current state and how long the problem is persisting, isn't it? And there is some analysis called 4W1H analysis, isn't it? We spoke last week also. You do that 4W1H discussion with all your project team and then convert the outcome of your meeting into a well-defined problem statement and why the project wise inclusion is very, very important. And for the project Y, yes, say within the charter, you write the formula, how to measure Y. Instruction on how to measure Y. Instruction on how to measure Y is known as operational definition. Is known as operational definition, and formula, unit, and everything is clear. And tell me which element of the project charter should talk about the process. Come on, answer this question. Which element? First of all, do you all remember the elements of the project charter?
Yes, sir. Yeah.
Yes.
Stratification.
So business case, problem statement, goal statement, project scope, and yeah, forgot the last one.
Timeline, team member.
Timeline.
These are
Timeline.
Stakeholders.
Yeah.
team member. These are 6 major elements. Of course, you can add no additional elements. There is no hard and fast rule. Now, within the 6 major elements, which element should speak about your process?
Process, I think the scope of the project scope.
Very good. The scope, in scope and out scope, you have to write. In scope and out scope. At the same time, the process starting point and ending point must be explicitly declared in your scope statement. Are you getting my point? Start point, end point. You know what is start point? The defect originating point. Whatever you identified, you can even perform a Gemba walk. You all know what is a Gemba walk, right? You go to the restaurant, manufacturing facility, go to the idli steaming line, and find out whether the problem is starting from the fermentation, or problem is happening only at the steaming station, or problem is happening at the packaging. You have to understand and draw a line. That line, one line for defect origination, another line for defect detection. Normally detection happens in a quality check. Yes or no?
Yes.
Defect detection is found at what? Quality checking point. Yes or no? Quality inspection.
Yes.
So this is called start point, end point. Your scope statement should necessarily have the start point and end point of the process that needs to be investigated. It is also important for all of you to identify the critical steps performed between the start point and end point. Do you understand? Walk, when you do a physical visit, when you are observing the, what do you call, the shop floor area where the problem is, getting originated, you are expected to note down the critical steps that are carried out between the start point and the end point. Is it clear to all of you? Let us say an assembly is happening, an assembly line, a nut has to be fitted and a bolt has to be, fitted, and then it must be tightened using a nut. And now problem is the nut is not fitted properly. This is the problem. The nut loosens, and because of that, a big major failure is happening. Now, all of you, please tell me what is the CTQ here? What is project Y here?
Torque.
Torque. Very good. The torque with which you have tightened the, what do you call, the bolt and nut is not really correct. Yes or no? That is what is actually causing the problem. Can you see a process behind this? Can you see a
Tightening.
process? What are the critical steps? Where the defect originated? The assembly line, so many parts are getting fitted. But in one particular station, the nut and bolt are put and then tightened by an operator. Can you take a chalk piece and identify the start point and end point in the line? Yes or no?
Yes.
After doing that, the critical steps performed in that place between your chalk piece line, start point and end point. What are the activities happened? The bolt is picked up, put in the place, and then nut is picked up, and
Securing,
put again bolt, and then a torque.
tightening,
Yeah, what do you call? How do you call it?
uh, securing, just securing.
Okay. So some kind of the tightening device is used, fastening device is used. But what's important is the torque must be set correctly. And the SOP says after tightening every nut, the torque must be tested, isn't it? The torque level must be indicated in the reading, and that must be observed, and then only part must be passed. But we don't know whether our operator is doing it or not. And so all these steps must be recorded, and then we can convert this information into a table called SIPOC. A table called what? SIPOC. SIPOC means
Supplier
SIPOC.
input, process output, customer.
Supplier, output, process, output, and customer. The P, you have to start with the P. P represents what? Process. You already identified the start point. You already identified the end point. And you also observed the critical steps performed in between, yes or no?
Yeah.
Already identified the critical steps in between. So all critical steps must be
Checked.
must be written, and then for each step, what is the output that is coming or output that is expected, and who will receive the output, and for each particular step, what are the inputs required, and who will supply the input, and whoever is supplying the input to a particular process step he is called as supplier. Okay, so you will be able to develop a kind of table. What do we call it as? A SIPOC, right? A SIPOC table or a SIPOC diagram, you can call it. So I'll just show you how all these things will look like in the slide. So once you have a clarity on project Y, you also have a clarity on your process, and then you have a great understanding about the problem. Okay. And then you can think about the measurability. Yes, of course, measurability has to be ensured in the beginning stage itself. And in the measure phase, you can actually measure, and you can check the current state of the problem. The measure phase purpose is current state. So I'll just show you, how a SIPOC will look like. So far, any questions? Anybody? You understood everything I spoke, all of you?
Yeah, sir.
Sir, in
Yes, sir.
Yes, sir.
project chatter,
Hmm.
I understood in the manner of in goal statement only we used to mention the present to target stage, right? Or target to be mentioned in scope statement.
No. In scope statement, the process must be highlighted. In scope process, as far as the process is concerned, starting point, end point, you must necessarily show in the scope, right? And so easily we could understand every step that is happening between start and end is in the scope, and also in scope and out scope. What kind of process? I mean, what kind of product? What kind of defect? Which particular line? Which particular factory? And these are all in scope.
Okay.
Out scope in the sense, whatever needs to be excluded. They're all called out scope. Okay. And target, we will be declaring in the goal statement. But current state must be declared in the problem statement. You can also describe the gap and consequence of the gap and duration for which the problem is experienced. All these things will be part of your problem statement. Somebody reading your problem statement should be able to easily understand the pain being experienced. But
Okay.
somebody reads your complete project charter, still they don't understand the pain you are experiencing. That means the project charter is not ready for approval. All these components will be evaluated. And problem categorization. All of you tell me, is it problem categorization very important or not?
Yes, sir.
Yes.
Problem categorization. When you see a problem, don't try to solve it immediately and see whether categorization is possible. If categorization is possible, choose the major contributing category and solve that one. And the lessons learned, solution generated out of that particular category can be horizontally deployed to other category if a feasibility exists. Are you getting my point? This point, these are very valuable guidelines when you are actually doing a project. People struggle a lot while doing a project simply because they lag in terms of clarity in all these elements we are speaking today. Many people, till the end of the project, they will be talking only about customer complaint. By simply talking about customer complaint, you will not be able to improve anything. Do you get my point? Why customers are complaining? Because defects are happening. Why defects are happening? Because your process is not capable. If you don't speak the language of the problem solving, you will not be able to solve any problem. Correct or not?
Yes.
Reducing customer complaint is not your problem statement. Those of you who are writing, reducing customer complaint from 4 per month to 0 per month, that means you don't know what is problem statement. You're not, that can be a beautiful project title for your management. Am I correct? Those who are writing problem statement in those manner, they have to go and sit in the customer place only and don't allow your customers to speak. You will, problem will be arrested. Yes or no?
Yes.
Those who really want to solve it, you have to speak, from the process perspective, project wide. I hope it makes sense, all of you know, listening to all these explanations. Though theoretical, you have to understand this, properly digest this. And when you actually go back and try to do a project, you have to put all your capability and skills in preparing the project charter. Many people, they take it very lightly. Just to take one paper and then they prepare the project charter in just 30 minutes and then they will not know how to proceed. Project charter should actually give you the complete direction. Oh, we have to do this one next. All right. So I'm just showing something here. VOC to CTQ drill down. You see here, VOC are nothing but the expressions or statements that drive customer satisfaction, the customer's language. They are vague. They are difficult to measure. See here, I don't want to wait too long to get my call answered. Now, all of you, please tell me, what is the pain metric that I need to fix to arrest this kind of customer complaints?
Waiting time. Waiting time.
Delivery.
This is about call center, isn't it? Can you see that by reading this? You can easily understand. The call center.
Waiting time.
Dial time
Hold
to connectivity time.
Now it's a call waiting time or call answering time. Call waiting time or call answering time. So, will you also be able to write an operational definition on how to measure the call answering time? Can one of you? What do we mean by call answering time? Whenever
We
you
need to collect the statistics of all the call and waiting duration.
exactly. So every time when we connect to a call center, then a recorded voice only first comes, isn't it? That will keep on be saying you that your call is very important. But the problem is nobody talks to us. The
After
call
five
is
minutes, are
very
disconnected.
after 5 minutes, 10 minutes, or sometimes after 20 minutes, and it
Then
depends
this
on the kind. Yeah, it depends on kind of call center.
I
Now
wait till I get frustrated.
we get frustrated, and you should be able to measure the call answering time correctly or call waiting time. The definition is the moment the call is connected until the moment a real executive connects over the call. The time lapsed is known as what? Call waiting time. Or do you understand, all of you? This definition is very important. And whatever minutes that is mentioned against each call, that is not call waiting time. That is no call duration. The problem is not call duration. If problem is call duration, and that's an altogether a different problem and different process needs to be looked at. Yes or no? If it is call waiting time, then the conversation has not yet started. Can you see that, all of you? How can
Right.
we minimize this? This is a different direction. It's an
Tapping.
altogether different problem.
We have to,
And
we have to see our number of executives ready for take a call and what is the response time immediately why they are not responding, or you can say
you,
the
if,
reaction time immediately.
correct.
Or
If
other,
you understand the problem correctly, identify the correct pain metric, then you will certainly be able to identify the correct process. Then only you will be able to identify the correct causes, right? And the root cause analysis can be performed, right? So, CTQ metrics are the measurable elements that define the customer satisfaction. So here I am naming it like this, call answering time, but you want to call it call response time. No problem, you call it. But what is the definition you give it? That's very important. Don't look for a dictionary definition for the terminology. You create the terminology, you write the definition. If you are depending on dictionary definition, you will be, taking the project in a wrong direction, right? So don't depend on dictionary definition. I don't want to wait too long to see my account manager. This is not over a call. This is a physically, customers are coming to our office, and they are trying to meet their account manager. And here also they are not allowed to meet the manager immediately. They are made to wait. This is a problem. Right. Now go through this question. If a customer segment complain about delay in responding to the queries, a metric that can be used to track the performance, which metric will you use?
response time.
Response
Response
time.
time.
Response time.
And also, just saying response time is not enough. And I will certainly not be accepting if I am reviewing your project. You have to write an operational definition for response time. And you
Yes.
should also assign a unit of measurement. Do you want to measure this response time in minutes, hours, or
In
seconds?
seconds. Seconds, sir.
Minutes.
Yes.
Ah, which is appropriate and makes sense to your project, that much, that kind of unit of measurement you must, prefer to work with.
Sir.
If a customer segment complain about a longer transaction, a metric that can be used to track the performance.
Transaction time.
Transaction time in
Transaction
minutes.
time
Transaction
Transaction.
time in
in minutes.
Because the same terminology is used, yes, transaction time is the correct answer. But what is most important? Your definition of transaction time is important. And how do you measure it accurately? That is much more important. Otherwise, if measurability itself is a problem, and there is no work for Six Sigma belt over there. Even non-belts
Sir,
can
here,
handle the problem.
sir, here we can look our system also. What is the transaction time as per standard operating procedure in our case, and what
Yes.
customer wants. We can compare and change it.
If your system is capturing the information and that is already readily available in accurate form, then you can use it.
Okay.
Okay. That
VOB,
comes from,
VOC.
very good. Voice of business comes from within the
Voice
business.
of business, voice
VOC
of
is provided
customers.
by. To capture the voice of the customer, it is important to collect data from a large representative sample of the target customer base. To collect this data, Six Sigma practitioners can use. Tell me which one Six Sigma practitioners can use.
Answers.
Surveys and
Survey and
questionnaires.
questionnaires.
The
Surveys and
survey
questions
and question.
can be more realistic.
Survey.
And this is structure of CDQ tree. Customers are talking like this. Good service is what they want. But good service actually mean knowledgeable representatives, friendly representatives, and short waiting time. Do you see different, what do you call, drivers appearing here? One is
Yes.
time related thing. Another thing is, a friendly approach.
Behavior. Behavior.
Third,
Delivery knowledge.
Behavior.
Skill.
the third one is the real capability of the representative, isn't it? Because customer
Yeah.
derive the satisfaction in three different areas. They are called drivers of satisfaction. Then from the each driver, we understand certain metrics. For example, knowledge of the call center executive. How do we measure whether the answers given by the executive are correct or not? Isn't it? You are asking me a doubt and I am not giving correct answer. So that shows a gap, isn't it? And representative can answer the questions on the spot. Your representative will research the information and return the answer very quickly. So all these things are helping us to what? Measure the knowledge level of the representative. Do you see, all of you? When we are on the left side, things are very vague and there is no measurability. When you come to the right side, it becomes measurable. Can you see that I can put a similar question in a questionnaire and send it to my customer, yes or no?
Yeah.
If you simply ask, whether service is good or not, and customer also will say it is good, and some customer will say bad, but what action will you take? So drill down, make the problem specific. Make the problem, see here, what is written here? Easy to
Easy
measure.
to measure.
Your customers are saying, I need a friendly representative. You need a friendly representative. What do you mean by that? That means customer must be greeted by name. Have you experienced whenever you talk to some call center executive, they talk to you like your friend. First they ask your name and then they started using your name 10 times. Isn't it? So by the time you become his best friend. So that is required. So customer greeted by name and the customer is not interrupted. When the customer is explaining his concern, customer should be allowed to explain. Are you getting it? So why are we writing all these things? Because we really wanted to improve the measurability. Because measurability is the key for root cause identification and action, isn't it? Short wait, time placed on hold, and customer transferred quickly to a person who can help them. Escalation sometimes, isn't it? Sometimes after engaging them for 1 hour, then they will say, sir, you called to the wrong section. I am now transferring your call to the next section. Now you will start everything from the scratch. That should not be the case. If the customer should be transferred quickly to the correct spot. And these are the factors that drive customer satisfaction. These are the metrics that we need to measure. If a call center measures all these metrics and perform in a better manner with respect to all these metrics, do you think customer complaints will continue to exist or will slowly go away?
They will reduce it.
So these are the metrics that you need to take care. All these metrics are process level metrics. Do you see that, all of you?
Yeah.
All these metrics are process level metrics. So likewise, you can actually go through the material and you can also write the CDQ metric for your problem, your metric, your process, which is very, very important. This is for a footwear. And these are the metrics, nothing but the product specifications, and which will directly, indirectly drive the customer satisfaction. And these are some other metrics. Maybe you can, some of them may be under the quality related, right? CTQs. Some of them may be CTPs. If you look at, these metrics, these are CTPs, like your cash conversion cycle, your EBITDA, your inventory turnover ratio, fault detected prior to failure, your mean time between failure, your percentage of total overtime, time from order to shipment, tag time, cycle time, operate. Do you think all these are language of your customer or language of your management?
The overall management.
Critical to business.
So management voice also can be used to identify projects, but you will land on CDBs. So hope you all now have some clarity on how to identify projects. And quickly I will show you the SIPOC and then we'll go for the break. Wait. This and all we discussed. See, I have put a very simple example so that you could easily relate and understand. And then when it comes to your process, yes, you can. See, what is this process named? Pizza preparation and delivery. Why we need SIPOC for a pizza preparation and delivery? Because there are customer complaints often telling that pizza is delivered late. Do you understand? Pizza is delivered late. If pizza is delivered late, you need to investigate the delivery process as well as pizza preparation process. Am I right?
Yes, sir.
The pizza delivery lead time means time between order and the delivery. So the first step is customer is placing the order. The last step is the delivery boys returns back or delivery boy hand over the pizza to the customer. So as soon as your outlet receives an order, what are the outputs produced? See here, this is a process step. All of you can see that. These are process steps. Customer placed the order. The order details are now transferred to the cook as well as transferred to the delivery boy. Then pizza is actually cooked. Then the cooked pizza is packed. Then the packed pizza is delivered. And then the delivery boy comes back and is now available for the next delivery. Now, all of you, can you see the critical steps that are happening between the start point and end point? If you are the pizza outlet manager, you can easily understand the start point is order received. Am I right?
Transfer details.
The end point is
Placement of
probably
order.
customer receiving the pizza. And these are the activities
Okay.
of
So, sorry, sir. Every process, the customer is changing. So, every process have a input and output.
yeah, there may be multiple process here or process steps here. It depends on the scope of the project. Sometimes it is drilling, man, and then shaping, and then some other finishing, some welding, assembly, and that way also it can be. But in such a case, the scope is very big. Whereas here, these are process steps. Customer places an order, and soon after the order is placed, the store will receive the payment, will have the cooking instruction, will also have the delivery instruction. Yes or no? These are the output. When you place an order, these are the outputs expected. Am I right?
Yes, sir.
And all these output, who will receive first? The store manager is the first person who will receive all this information. Whether the
Orders.
payment is promptly received, whether the product details are clearly mentioned, whether the delivery details are fully available. And once all these things are so that means all these output are required by the store manager. Then what will happen. The next step will be he will be transferring this cooking details and the delivery. He will retain the payment, and cooking detail and delivery details will be transferred to the cooking person and the delivery person. Now the store manager become the supplier. isn't it? For this step. Am I right?
Correct.
Because he has
Yes,
to
sir.
provide the information to the cook and to the delivery boy. And now the output is the correct cooking instruction and delivery instruction, which will be received by the chef, who is the customer for the second step. And also the delivery boy is also a customer because he has to know the delivery details and order number so that he can be ready to stay ready to collect the pizza and deliver the item. Are you getting it? Now the next step, the pizza is getting cooked. And for that, some pizza topping, some ingredients are to be arranged. Who will arrange? The chef himself will arrange. Do you understand? Or if he has got an assistant, and you can write assistant here. The assistant to the chef becomes the supplier. If there is no assistant available, the chef himself is the supplier. The chef himself is performing the process, and the output of this process step is a cooked pizza. And now the cooked pizza is going to the packing section. Are you getting it?
Yes.
Now the pizza is packed. And for packing of the pizza, we need the packing item and the cooked pizza. And these things must be supplied by the packing
Okay.
staff only. You have to pick up the item and all that. And then the pizza box, the invoice, the delivery address, and all these things are handed over to the delivery boy. Now the pizza is delivered to the customer. In order to do this step, the packed item, some vehicle, the route instruction, all these things he has to arrange himself. And the ordered pizza with the bill is delivered to the end user. Now the delivery boy returns. Now all of you, do you see all the major steps involved in this process of this project is all about delivering the what do you call uh,
Pizza in a time.
Yeah. Reducing the order lead time. Reducing the order lead time. Right now, every time an order is placed, more than 1 hour is consumed to receive the pizza. And so, in that outlet only, the pizza company is facing less order and so many customer complaints. So, they want to reduce the order processing time or order lead time from 60 minutes to less than 30 minutes. This is the project goal. Do you see a project Y here? All of you, do you see? See, customer complaint is not a project Y. What is project Y?
Delivery time.
Packing
Order
time.
Delivery
processing time.
time is the
Delivery
delivery
time.
time.
And order processing time is the project Y. And these are the. Can you see the stakeholders here listed under the column supplier, and also listed under the column customer. These are the
Customer.
people related to the process. So they are called stakeholders. Somehow you involve them in your project at appropriate stages, and you will be able to fix the root cause. And similarly, you can think of SIPOC for a welding process. I'm not going to read this out because only welding related terminologies are there. And similarly, for your project in which you want to fix a particular problem, you should be able to develop a SIPOC. See, all these things will bring enough clarity in the project you are going to do. If there is a lot of clarity and there is a guarantee of results to be delivered. If the clarity is missing, I don't think, the team will deliver the result. Clear, all of you?
Yes.
Any questions? Helpful?
Yes.
So what
Yes,
is
sir.
expected from all of you now? What is expected now from all the participants? You should
Mhm.
be able to prepare
Epoch.
an executable a project charter for an executable project. If you submit a project charter, it should only be approved and then executed. Ready to approve project charter. So if you include all these elements and make it the way we discussed right now, your project proposal will immediately be approved. Okay. So we'll take a break here and then we'll continue sharp after 15 minutes. Okay. No. So now we will proceed and then try to understand two topics. One is the gauge R&R study. Another one is the process capability analysis. So prior to that, yeah. And do you see what is this, all of you? Front
Yes.
shock absorber mounting process, isn't it? And see, whatever we discussed right now, the same thing is now used for a shock absorber mounting process. How a shock absorber can be mounted, you know, what do you call, the chassis. Problem definition with the 4W1H. And see, this is how the application of a Pareto in a particular problem. Yeah, I only wanted to show you this. What is that? Pareto, Cyborg. This is data collection plan. So if you are collecting the data, how the data should be collected, the definition for each and everything has to be included. Well, probably, yeah. And this is like, this also you should see. What is that? Yeah. Process flow diagram. You know what is this? Whatever is your starting point and ending point, the process flow indicating all the steps. See, initially you can start with what? Initially you can start with the SIPOC. But after the SIPOC is developed for a detailed investigation, you may have to convert your SIPOC into a process flow diagram or sometimes into a value stream map. It depends. Yeah. So ultimately, we need to have a complete clarity on what we are doing. All right. So shall we proceed to the next topic, all of you?
Yeah.
Right?
Yes.
Okay. So I feel all of you are now confident about the define phase. So we should not be making any mistake in define phase because define phase is like planning your project. If you plan badly, it's like, planning for a failure. So you have to have a plan which is, executable. So all efforts, whatever efforts you can put in, please put it in the project charter level itself. The project charter level itself, you must put in and the charter must get approved. All right. So now gauge R&R. And tell me what is gauge R&R means. Gauge repeatability and gauge reproducibility, right? Yeah,
Error. Error.
Yeah. So let me close. These things are not required for some other purpose.
Used
Okay.
for the continuous data.
Yeah. Yeah, this for continuous data. So now what you see on my screen is nothing but actually a Minitab software. Have I shown this Minitab software to all of you earlier or this first time you are seeing?
Last week, sir.
Last week also I have shown. Yeah, last week already you have seen that. Good. So let me use this because the gauge R&R study, a lot of calculations involved, and we are not going to focus on the exact, the calculation steps and all. Rather, we will understand the concept and we will see how we can use Minitab. And because Minitab will manage all the calculation steps, and we will be interpreting, the output of the gauge order study, and then we will ensure the measurement system is error free. Okay. So gauge R&R study. First of all, why this study is required? Why this study? The study is required to validate measurement system. Are you able to see my typing? All of you? You are able to see, right?
Yes,
Yes,
sir.
Yeah. Validate the measurement system. Why the validation is required? Because we doubt our measurement system might produce error. Why we are so serious about the measurement error? Because it's a data intensive project, we are doing. So data quality is very important. Otherwise, it will be a garbage in, garbage out scenario. So we should be careful that the data we use in all our analysis is error free. And there is a guideline by AIAG, the guideline by AIAG that says the gauge R&R, shortly called as gauge GRR, should be below 10%. Can one of you tell me why it should be below 10%? Any idea?
To
Anybody would like
ensure
to
the
answer?
repeatability and reproducibility, give us the accurate value.
Yeah, the repeatability and reproducibility are very important. So why it should be below 10%? Because the bias in your readings or in your data should be below 10%. The bias in our data should be below 10%, which is possible only if gauge R&R is below 10%. Okay. So prior to that, what is bias? Bias is nothing but the difference between the true value and then the observed value.
Observed value.
Observed value, you can also call it measured value, right? And if you take multiple readings, because there are some replications, then it should be average of the measured value, right? And the bias can be positive or negative. Do you know what is positive bias? Positive bias means measured value is more above the true value. Negative bias means the measured
Below
value
the
is below the true value.
Below the true value.
We don't want bias. So we wanted to eliminate the bias. We want to eliminate bias. If you want to eliminate bias, you must eliminate the bias from the measuring instrument plus
measuring person.
reduce the bias from measurement system. There are two components of bias. One component is originating from the instrument itself. Let us say my instrument, the spring is worn out and the condition is bad. So what will happen? My instrument itself is produce error. Possible, yes or no?
Yes, sir.
Are you attending? Yeah, please, don't hesitate to interact. So one thing is eliminate bias from the measuring instrument. Because why instrument can produce bias? Because it has become old, because some of the parts are worn out,
Not
because some oil.
calibrated.
So many reasons. All right. So if you want to eliminate the bias from the measuring instrument, you can calibrate your instrument. How to eliminate the bias? You can calibrate the measuring instrument and ensure you do this at appropriate frequency. Calibrate frequency also need to be maintained. Okay. And ensure your instrument condition remains stable. Do you understand all this language, all of you?
Yes.
Yes, sir.
So your instrument should remain stable. Stable means you should be able to retain the condition over the period of time, the required period of time. If you are calibrating 6 months once, and then 6 months the condition should be same. In such a way, you have to maintain the instrument. Yeah, usage instruction, cleaning instruction, everything should be available. So the possibility of error populating from the measuring instrument can be. But the other component, the another component. What is the another component? The bias populate from the measurement system. In order to understand this, first you must understand what is measurement system. Can one of you answer this? Measurement system means what? It's a group of elements, isn't it? Always system means so many elements. What are the elements inside? There is an instrument available, am I right?
Instrument,
Who
operator,
operator,
price,
sir.
environment.
Very good. Environment. Then
Time. Measurement time.
the instructions.
Scale.
The instruction given for measurement. This is what is called as operational definition. Very, very important. You remember last week I played a video, right? My computer video. You remember?
Yes.
Is it Dhoni's
Yes, sir.
video?
Yes, sir.
No.
No, I played my computer video. No, I played or not?
Yeah.
Yeah,
Yes.
yeah,
Sir.
my computer video. Yes.
Not delivering properly
Yes, sir.
instruction.
Yes, sir. My
Um,
computer.
That is very much important here. Proper instruction, right? In the instructions for how to measure, where to measure, how many readings, and the conditions for collecting the readings. Everything should be part of your operational definition. Very good. Then the part and characteristics to be measured. Do you agree, all of you? This is also important. If the part is very, very small, difficult to handle, that itself will become a reason for error population. Am I right? Certain parts are easy to measure, certain parts are difficult to measure. Certain characteristics are easy to measure, and certain characteristics are difficult to measure. Is this statement true or not?
Yes.
Yes.
Oh, time is
Yes, sir.
9:15. So you all are getting a nice sleep now. Is it so?
Oh.
Hmm. Yeah,
No.
you
No,
discuss
sir.
and learn. Yeah, please. Then you have to discuss and learn. And otherwise,
Sir,
no, then I
sir,
will also just run.
there is one confusion here. Where from this drive 10% bias? Because I'm not getting any thing in there. Why the 10%? Why not 8% or why not 12%?
No, I don't get you. I don't get your question. Come again.
I'm saying this 10% bias, and I just want to know what is the genesis of 10%. Why not 5%, 8%, or 12%?
Oh, you are now doubting the rule creator himself. It's
I just want to understand, sir.
yeah, somebody created the rule standard. No, see, experience only.
Mhm.
Right? So, how many times you are taking food every day? How many times you are taking food every day? 2 times or 3 times?
Why 4 times?
Why not 4 times? Why not 5 times?
Yes,
Right?
yes.
So it all,
Always 3 times.
Depends on our experience. People have found similarly, but the agency which has given that guideline is AIAG. I think I have mentioned somewhere, right?
Yes.
Agency AIAG. What is AIAG? Automotive Industry Action. Automotive Industry Action Group. But when I explain, you will understand. See, 10% refers to 10% of the operating range. What is your operating range? USL to LSL, yes or no?
Yes.
What is USL?
Upper specification limit.
LSL means lower specification limit. These are the limits given by the customer. The midpoint is normally the target. The midpoint of USL and LSL is the target. So now, let us say a particular part, it has to be produced for 100 mm thickness. The thickness must be 100 mm. And customer says plus or minus 0.5 is acceptable. That means what is your LSL here?
99.5.
Very good, 99.5. And USL will be
100.5.
0.5. Now, what is the range? The operating range is 100.5 minus 9.5 is the operating range, or otherwise I would say the total tolerance available is 1 mm.
1 mm.
Tolerance is nothing but USL minus LSL, right? The total tolerance. 0.5 on the right side, the 0.5 on the left side, so the total is 1 mm. So now the guideline says the bias must be 10% of the total tolerance. Total tolerance is how much? 1 mm. What is 10% of 1 mm?
0.1.
What does it mean? It means every single reading can have a maximum of 0.1 mm bias, not more than that. Are you getting it? So if 0.1 mm, see, the 0.1 mm, because see the 0.1 mm is generally permissible. If the gauge order is found to be 0.1 mm and if the bias is also expected to be 0.1 mm, then the measurement system is considered to be capable. Say for example, 100.45. A particular part is produced and its dimension is part dimension. Part dimension is 100.45. Now your measurement system has a bias of how much? 0.1. Right?
Till 100.55.
Okay.
So the measured value will be how much? 100.55.
Yes.
Now the part is should be accepted or rejected?
Shall be accepted.
Accepted.
See, customer has given you upper spec as 100.5. But your experiment, your measured reading, your instrument reading is telling what? 100.55. Now in this scenario, what will happen?
Rejected.
Your measurement system.
Only
Your measurement system.
0.1
Rejected.
Please note, your measurement system is rejecting the good part.
rejected.
Actually, the part is good. But your system has rejected it. Because of what? Because it had a bias of. Now this issue is happening. It's a same side goal, isn't it? You yourself reject your good parts. This is called
Over reject.
This is called type 1 error. Also called as manufacturer's risk. Also called as manufacturer's risk. It's called type 1 error. And see, type 1 error is not preferred. If it is 0, well and good. But it cannot be 0. It cannot be 0. If I ask all of you to measure something, do you think all of you will measure correctly?
No.
No, sir.
No.
No,
If you
different
need
person will measure different way.
definitely there will be an error, and that is why some allowance is given. Because if you are too strict, then also people don't like you. So always some 10% of the but see, it is given in proportion only. Out of the tolerance, 10% is the permissible bias. And because bias is a function of two things, one from the instrument itself, another one from the measurement system. Measuring instrument, measurement system. For the measurement system, we call it as gauge R&R. Ultimately, gauge R&R will become what? Bias. Are you following me, all of you? Gauge R&R will become what? Bias. But this bias is populating from measurement system. Plus, if the, what you call, again, if the instrument is not calibrated, then the instrument will also populate certain bias. There are two components of bias. The bias that is populated because of poor condition of the instrument. Another thing is, because the whole system is not performing in a uniform manner, there is a bias getting populated. So what we need to do is we have to calibrate the instrument. Always use a calibrated instrument. So the chance of your instrument error is eliminated. And then, but still the chance of measurement system populating the error cannot be eliminated. And so a permissive certain value is permitted, 10%. And I'll tell you, the error from the measurement system, which is nothing but a result of inconsistency in the measurement system. Inconsistency in the measurement system. Do you all understand what is inconsistency? Consistency means all the elements in the system should perform in agreement to each other. Now this inconsistency is known as precision error. This inconsistency is known as precision error. I think I have already taught this, at a lower level. Now, let's do a small exercise. Let us do a small exercise. In this small exercise, what I am going to do is, I'll play a song from my side. What will I play? I'll play a beautiful song from my side. Now, all of you have to measure the duration of the song. All of you have to measure the duration of the song, and then you have to type the duration measured in the chat box. All of you, is the operational definition clear to you? Is the operational definition clear or insufficient? In my opinion, it is insufficient. I only told measure, but how to measure I did not tell, isn't it? So all of you use a stopwatch. Do you have a stopwatch in your mobile phone? You can open the stopwatch from your mobile phone and you can show it in the camera, right? Yeah. Open the stopwatch and show. All of you should have the stopwatch with you. Now, all of you, please find out the resolution of the stopwatch and type it in the chat box. Do you know what is resolution? Least count.
Least count.
Minimum possible reading. What is the lowermost reading that can come out? Can you check? Can you check and type it in the chat box? Let me see whether all of you are. This is a problem. Lowest reading possible. Why somebody said milliseconds. Milliseconds is the unit of measurement. That is not the lowest reading. The lowest possible reading, how can it be 19? It cannot be 19. The first correct answer is Asif Sheikh. Asif Sheikh clearly mentioned 0.01 second. That is the correct answer. All others you have to correct. Even 0.001
I
mm.
think I too.
can time be measured in millimeter? Please note. If you are not thinking in the logically correct manner, you cannot be a leader. You cannot be a project leader. You will be, big confusing confuser in the company. If you confuse everyone around around you, do you think your team will produce result? No. Like the my computer video, you recall similar situation, will be created. So 0.01 second. What is 0.01 second?
100 parts of
Please count.
second. 100 parts.
1 by
1 notice 100
100th,
parts.
1 by 100th part of a second. You have to divide your second into 100 parts. Then each part is 0.01 second. You can call it 0.01 second, or if you want to name it, it is centiseconds. So those who used milliseconds, you are also wrong. It is centiseconds, right? Okay. Now I expect all of you to measure the duration of the video that I'm going to play in terms of seconds, not milliseconds, not minutes, not hours. Do you all agree, first of all? Do you understand my statement? You all must measure duration of a video I'm going to play in seconds.
Seconds.
So you have to convert all your readings into seconds and then only you should type it in the chat box. What I want is, I want all of you to measure the same way and get me the same reading. Are you getting my point?
Yeah. But
Because the expectation is all of you are going to watch the same video, isn't it?
Yes.
yes,
All of
sir.
you are watching. So, all of you are expected to give the same reading. But upfront, I think all of you agree it's not going to be same.
Yes,
And
sir.
so there is a clear evidence that we cannot achieve a perfect consistency. That's not going to be possible. Since perfect consistency is not going to be possible, there will be an error definitely. So we have to tolerate certain error because it's a human nature, isn't it? Because every system will have a certain thing. So normal practice is 10% of the tolerance. So knowing the tolerance is very important to understand whether your error is acceptable or not. Right? So now let me play some video. I just pause that. Play the same song. If I play the same song one more time, first of all, what we experienced is the variation we experienced is a measurement variation. We gave it a name. The name is reproducibility error. If I play the song one more time, how many of you are confident that you will produce the same reading? And here the expectation is I will also play it for the same duration. If I play the same song for the same duration, how many of you are confident that you will produce the same reading? Anybody here?
There will be
No.
an error.
Not
Not
possible.
possible.
There,
Not
there will be an
possible.
error.
There will be a
Not
minimal error.
There will
possible.
become
Yeah.
in milliseconds.
Means all of you are now ready to populate another type of error called repeatability error. You are not agreeing to your own reading. Just 1 minute before you produce the reading, but after that 1 minute, you are not able to produce another reading. This is called repeatability error. I think you all understand the concept, isn't it? I don't need to play the same song. Or do you want me to play the same song? Not required, right? Okay. So, there is a repeatability error possible. There is a reproducibility error possible. Now, we have to quantify these errors, isn't it? We have to quantify. We have to quantify. But please note, when we do a gauge order study, we are not involved in actual data collection. Then what are we doing? We are only doing a small sample data collection we are doing, isn't it? We're doing a small sample data collection. And so we can get a estimation of the error. What we can get? We can estimate the error during the sample collection, sample data collection itself. If we are committing error, then what will be the total error we will commit? Are you getting my point? Logical, isn't it? So, say for example, you look at our, the data produced, data available in the chat box. Pick up the lowest reading. What is the lowest reading? Is it possible to find out?
17.
Somebody typed 40 seconds. That means he enjoyed the song very much. For him, it is very short. Yeah. For some people, it went up to
81.
81. So 40 to
70.
81. The
78.
lowest is 40, the highest
71.
is 80. So the difference is how much? 41 seconds.
41.
The difference between the lowest is known as range. Is known as range. Maximum minus minimum. The range is a representative of the variation in your data. Do you all agree? The range is a representative of variation in your data. But the better representative of variation is standard deviation. Better representative of variation is standard deviation. Do you all know how to calculate standard deviation?
No, sir.
So we must learn.
Frequent.
Okay. So, okay. I think let us learn the standard deviation calculation right now. Okay. So the Google screen we'll use. And see, they'll assume there are set of data. Let's say, just to keep it simple, let me have, just 2, 3. Just 3 data points. I am only taking, very, very smaller number of data points. How many data points I have written? 3. Now what we need to do is, we need to calculate average. Average is how much here?
3.
Average is 3. Now, we need to find out the deviation of each point from the mean value. Mean is nothing but average, right? What is the deviation of first point from the average? 2 and 3?
1.
Minus 2, 0.
One,
Plus 2.
sir.
Minus 2,
1
0 plus 2.
plus 1.
Minus 1, 0 plus 1.
Very good. Now I want you to calculate the total deviation, sum of the total deviation. Sum of the deviation is 0. Can you see that?
0. Yes.
2.
If the total deviation is 0, but there is still a deviation inside, yes or no? Total
Square
deviation is
per
0, but deviation inside. So in order to capture the deviation, I have to convert the data into a square. This is called squared deviation. What is this called? X minus x bar the whole square is called squared deviation. When a square, minus 1 will become plus 1, 0 will be 0, plus 1 also will be 1. And so now the total of the squared deviation, this is called sum of squared deviation. Do you all understand? In statistics, this is called SSD. SSD means what? SSD means what?
Standard
Sum of the
deviation.
square
Sir.
deviation.
Standard deviation.
Sum
Square standard deviation.
Square
Square
deviation is the
standard
sum.
deviation.
of squared deviation. The sum of the squared deviation, which is x summation of x minus x bar the whole square. If this is divided by n minus 1, this is known as variance. Sum of the squared deviation divided by degree of freedom. Approximately, we can call it as average of squared deviation is n minus 1, because we are dividing by, instead of n, we are dividing by n minus 1. You know why n minus 1? Because we are dealing with sample data. When we are dealing with sample data, it is n minus 1. If you are dealing with the complete population, then it can be n.
N.
Now, in this case, our sum of squared deviation is 2. What is n minus 1? N is 3, because we took 3 samples, isn't it?
2.
2.
So n minus 1 will also be 2. N minus 1 in statistics is called as degrees of freedom. N minus 1 in statistics is called as degrees of freedom. So 2 divided by 2 is how much? 1. All of you, do you understand how the standard deviation is calculated?
Yes, sir.
First step, what should we do? We should calculate the mean. First column is mean. Second column, deviation from the mean. Third column, squared deviation from the mean. Then from the squared deviation, we have to find out SSD. You know what is SSD? Sum of squared deviation. Column 3 must be summed up. Then sum of squared deviation, when it is divided by n minus 1, we get what? Variance. Sorry, variance. The symbol of variance is sigma squared. This is variance. But what is required? What is required is standard deviation. Standard deviation is sigma. So sigma means you have to take square root of variance. Are you getting my point? So should I just remove this, erase this? Or I will just write here. Now standard deviation is equal to square root of variance. What is variance? Sigma square. And how much it is? 1. What is square root of 1? 1 only.
1.
So in this case, a peculiar case where standard deviation is also 1, variance also 1. Do you understand, all of you, how this is calculated? Come on, tell me.
Yes, sir.
Have you understood? Very
Yeah,
simple formula. Thereafter, you should not be struggling, or you don't have to do all these calculations manually. You can ask Excel to do it, isn't it?
Excel. STDEV.
Variance.
E.S. Or you can also use Minitab and do it. All right.
Hello. Sir, I have one question.
Yes.
How we calculate the summation of x minus x bar? I didn't get that. I got the square, but I didn't get how it comes 0.
Summation.
You're asking about this?
Yes, correct.
It is 0 only, no? Only 3 numbers are there. -1, 0, and +1. You add.
Okay, clear.
-1 +1 will cancel each other. Then the
Okay,
balance, the other is already 0. So the total is 0. But we
okay.
want to capture, that's why we are squaring. And now we are going for squared deviation. And so we call it sum of squared
Square
deviation.
standard deviation.
Sum of
Yes.
squared deviation is divided by n minus 1. And then we take a square root of the variance. So the formula for standard deviation will be summation of x minus x bar, the whole squared,
N minus 1.
divided by n minus 1. And all of you please note, you can use two symbols. One is sigma, other one is S for standard deviation. When to use sigma? For population. When to use S? Sample. So there is sample standard deviation possible. There is also population standard deviation possible. Are you with me, all of you? If you know, if you think the data you are
Yes.
using is population, then only you should use the symbol sigma. If your data is a sample, then you must use the symbol capital S. The difference in the calculation method is sample standard deviation, the denominator should be n minus 1. But for population standard deviation, the denominator must be
N.
n only. N minus 1, how do we call it? N minus 1, how do we call it?
Degree of freedom.
Yeah, freedom.
Degree of freedom. Yes, very important. All right. So now you know little statistics. And all of you please note, whenever you collect data, whenever you tabulate data, whenever you visualize or you produce some graph or you do some analysis, you are actually You are actually, using statistics. So statistics is nothing but a science. Statistics is nothing but a science of collecting, tabulating, right? Organizing, visualizing, isn't it? Analyzing and interpreting the data. For what? For making effective decisions. Do you all understand what is statistics?
Yeah.
For decision making purpose, you are using data. Okay?
Visualization.
So you have to carefully design your data collection approach method. That's why, in measure phase, we have to create a data collection plan, write the operational definition and define who should collect data, define at what frequency should collect data and all those things. So this is called statistics. And statistics, you all must understand there are two categories of statistics exist. One is descriptive statistics, another one is inferential statistics. I will type it. I'll type it in the chat box. Descriptive versus
And
descriptive. Another one is inferential.
in
Descriptive versus inferential.
sir, you have not
Let us
displayed.
say descriptive. In the chat box, it is there. Descriptive versus inferential. Right now in the meeting, how many people are attending our meeting right now at 9:15?
15.
32.
32.
32.
Out of 32, how many people are staying on the camera? 1, 2.
All.
Not all are staying on the camera. I'm not asking to come on the camera, but I'm only asking somebody to count. Okay. So many people are on the camera. That is good. This is how the screen should be. Screen should be colorful. Okay. Let's say some 15 people are on the camera.
10.
Remaining are off the camera. And how many people were today? Some what to say, orange color dress. Mine is also included as orange. Ajay is also in orange.
Yes.
I think Madam, you are also wearing orange color dupatta. Okay, some orange color, how many? White color, how many? Blue color, how many? We are collecting data and we are putting everything in Excel. And how many people are in the age group of below 30? How many are 30 to 40? How many are above 40? These kind of analysis we do. That means we are actually doing statistics, isn't it? Yes or no?
Agree.
Yes.
I can
Yes.
about all of us, put it neatly in an Excel table and give a printout to all the participants. This is called descriptive statistics. This is nothing, difficult here, isn't it? Very easy, yes or no? What is the age group and what is the name and what is the color of the dress they are wearing? How many actually boldly attending the sessions on the camera? How many are immediately going off the camera? These kinds, some information about our process is collected, tabulated, and copy is given to all the participants. This is called descriptive statistics. Okay. Now for my next batch, how many people will join from Pune? How many people are expected to join from Bangalore? Because I have some data already about so many batches, and I am trying to judge how many people will join our online training from Pune, how many will join from Bangalore, how many will join from Delhi, how many from Mumbai, how many from Chennai. Will you be interested in getting such predictions? Yes or no? Very helpful for business. Am I right or not? But how do
Yes.
I get answer from the existing data only, isn't it?
Previous forecast.
If you use your data for the purpose of prediction, then your statistics is called inferential statistics. Do you understand, all of you? There are two types of statistics. You all must be too good in both type of statistics. Then only you will have an effective decision making capability. Are you getting my point? All of you must equip yourself very strong in descriptive statistics as well as inferential statistics. When a cricket match is played, if a batsman is coming inside the ground, and they show a lot of data about the batsman, isn't it? His name, his age, his debut, how many centuries he scored, how many 50 he hit, what is his strike rate? What is this? What is this kind of statistics?
Descriptive.
No,
It is
prediction.
descriptive. It is not a prediction. It is his past performance. It is not. No, there is
Okay.
no challenge over there. Already information is available. That information is just presented to you. It is descriptive.
Okay.
Yes.
It is descriptive. In defined phase, we have to describe the problem with the data. It's a kind of descriptive statistics, isn't it? You are backing your problem, with some data. It's a descriptive statistics. But when India and Australia is playing, during half of the match itself, an announcement is coming. The chance of India winning the match is 70%. The chance of Australia winning the match is 30%. Match is still not
Inferential.
Very inferential.
Differential. Yeah.
differential.
Prediction.
Prediction. And somebody is asking you who will win the match. Now, how will you answer? India will win. You know why?
India.
Because chance of India winning is marked as 70%. So when the probability of success is known, you can easily make a decision. Yes or no?
Yes, sir.
Probability of
Yes, sir.
success is 70%, and the balance 30% is probability of failure. You all must believe your data, make decision if the risk of failure is limited to 5%. Risk of failure should be limited to, if the risk of failure
Right.
is limited to 5%, yes, you can believe the data, and you can use the findings from the data, and then you can declare it. If the risk of failure is 5%, then the remaining percentage, 95%, the probability of success is termed as confidence level. It's termed as confidence level in our data. Do you understand certain terminology now related to statistics, all of you? Because slowly you should also be using statistics comfortably in your project. All of you know what is statistics?
Yes, sir.
All of you know
Collecting,
descriptive
comparing,
Yeah.
interpreting data.
Yeah, statistics, descriptive statistics, inferential statistics, probability of success, probability of failure, right? The risk associated when there is 70% failure for success chance, 30% failure chance, and you still say India will win the match. What is the risk involved in your announcement? 30% risk, isn't it?
30%.
This much risk is not permissible in statistics. Like gauge order, how much risk is permissible? 10%, right? In inferential statistics, only 5% risk is permissible. General practice. If you want, you can change and then you can declare. Sir, my prediction comes with 10% risk. You can tell, nothing wrong. So people then immediately understand the quality of your statistics, quality of your data. Yes or no? So whenever you use statistics, you should also declare the risk. If the risk is, but if you could reduce the risk to 5%, then it's an excellent finding. Statistically, your findings are considered to be, significant. Now, the others also will also agree. So if you limit the risk involved or risk of failure to 5%, that means you have achieved a confidence level of how much?
95%.
So this much statistics is enough today. But slowly we will use data, and then you will be very comfortable in all this terminology, and then you will be able to better relate. So going back to gauge arc. In between, I just took a turn. I talked about what?
Standard
Statistics.
deviation and statistics.
In a broader sense, because all of you are studying Six Sigma, so you should not be saying, I don't know how to calculate standard deviation. That's why I've shown how to calculate. I just shown it for 3 data points. Even if there are 300 data points, the method is same. And I don't want you to do anything, manually. Because I know if you do manually, everyone will do it, wrongly only. So don't test that. What you can do is you can use Excel, or you can use, Minitab, or at least you can use any AI tool that you are familiar with.
ChatGPT can.
Yeah. But then, if the AI tool makes a mistake, you should be able to point out, right? You should be able to find out because you are accountable for, the findings. You cannot say, sorry, sir, I used AI, so I don't know what I presented. That you should not talk like that. If you can use AI, but the accountability is yours. Those of you who understand, yes, you are most welcome to use any AI tool that you are comfortable with. You can do, all the analysis. See, all of you, please note all the analysis, all the things we are teaching here. You can get it done easily with the AI tool. Nowadays, the AI tools are not so much capable. They can do all sorts of statistical analysis. But you can start using it only after knowing the concept and everything, isn't it? So if you know what is statistics, inferential statistics, tools like hypothesis testing, then you can use AI tools for actually doing it in your project. Nothing wrong and nothing harmful in it. Okay. Now going back to gauge R&R study. So what I do, I go to the mini tab now. My full screen. Now this is mini tab. Okay. So error from the measurement system. There is inconsistency in the measurement system, which is generally called precision error. But the precision error can be of two types. You know what are the two types? One is reproducibility error. You all experienced it today. Another thing is repeatability error. Unfortunately, we did not play the song for no second time. And if we would have played, definitely you could have realized you cannot match your reading. Even if I match the duration, you will still not be able to what? Match your reading. So there is reproducibility error, there is repeatability error. Sum of both is known as what? Precision error. And now, by the way, how to estimate this reproducibility error? All of you know there is a way by which there are formulas by which we calculate standard deviation of data. Yes or no? There is a formula to calculate what? Standard deviation. Am I right? So, for reproducibility error, there is a standard deviation. See, here the trick is how you handle the data. If I handle the data in a particular way, I will get reproducibility error. For example, all of you have typed the data in the chat box. Am I right? All of you have. If I use that data and calculate a standard deviation out of it, I already calculated range we have calculated. Have you noticed 41?
Yes, sir.
That range is a representative of reproducibility error. Similarly, I can calculate standard deviation. That will also be a representative of reproducibility error only. But if you want to go closer to the exact reproducibility error, you have to multiply the sigma by 6. Do you understand, all of you, what is the formula for calculating the reproducibility error? 6 times the standard deviation for the reproducibility data. All right. See, data has to be organized in a particular way, and we have to calculate a standard deviation. Then that standard deviation will represent what? Reproducibility error. So I don't want to complicate the topic. Similarly, we can calculate a sigma in another way, and so we'll get the repeatability error. But once the standard deviation is calculated, again we have to multiply by 6. So 6 times of standard deviation. Please note, all of you. 6 times the standard deviation is the spread, is considered as the spread of any data set, right? Or we can say it is the spread of distribution. We call it distribution, where data is not distributed. So that is one reason the methodology is named as Six Sigma methodology. Because any distribution will have a spread of how much? 6 times?
Sigma.
Tell me, any data will
6
have a
times
spread of how much?
standard deviation.
6 times standard deviation. Then, so if I take 3 times standard deviation, I will only get the spread on one side 3 times. Oh, sorry, 3 times standard deviation will be equal to half of the spread. And another half will be another 3 times standard deviation. So 6 times standard deviation is considered to be the total spread of any distribution. And so keep it in mind. We'll again come to all these concepts. So the repeatability error and reproducibility error together is called precision error. I call it repeatability error plus reproducibility error. What I want now is the gauge order. Gauge order. Gauge order is nothing but the precision error. The calculated precision error compared with the tolerance given by the customer, which is nothing but USL and LS. And I have to multiply that by 100. I have to multiply that by 100. And this gauge R&R, GRR, this GRR must necessarily be less than 10% to say that our measurement system is acceptable. If the GRR is in the range of 10 to 30%,
Conditionally
then
accepted.
Conditionally
yeah,
accepted.
Conditionally.
the measurement system is conditionally accepted. What is the condition I told you?
Six Sigma level. Standard deviation 2.
Remember, CPK should be
Okay.
more than 1.6.
1.67.
Only in such conditions, that too, you have to understand the scenario and you can allow them. But when gauge R&R is more than 30%, the
Not
measurement system is
acceptable.
Not acceptable.
unacceptable. All right. Now, few other guidelines for conducting a gauge R&R study. You have to select minimum 10 parts for performing the gauge R&R study. You understand, all of you?
Yes,
And the
yes, correct.
sample parts must cover the specification range. What is another condition? Specification range means
Upper
USL minus
specification limit and LSL.
must select parts closer to USL, also closer to LSL, also in the center. Center is the target. Do you understand the second point, all of you? Your sample parts must cover the entire specification range. You must have samples picked up closer to the spec as well as picked up closer to the center. Okay? The ratio of good versus bad should be known to you while conducting the gauge order study. Then what is good? The samples closer to the center
Mean center.
are good parts, are good samples. But the samples closer to the specification limits are the bad parts. Do you understand, all of you, the guideline?
Yes,
But
yes.
these are confidential information. Only you should know while conducting the gauge order study. The people who are actually involved in the measurement, they should not know about all these things. All right. And now, you 10 parts you have taken, and you need to select appraisers. Select appraisers in a logical manner. Normally, the number of appraisers normally can be 2 or 3. Why 2? And 2 or 3 must represent the whole set of data collectors. If there are 10 people who are expected to be involved in the data collection, then out of the 10, you can randomly pick 3 and they should be involved. So 10 appraisers, 10 samples. How many appraisers? 3 appraisers. Then each part must be measured by each appraisers at least minimum two, and I would suggest go for 3 times, minimum 3 times, and this is called replication. What is this called? Replication. Why are we replicating the experiment? Because the same operator, same part, same measurement, he will measure 3 times, but at a different time, not at the same time, right? Then only we will be able to understand the repeatability error. Hope all of you understand. So now 10 parts or 10 samples, 3 appraisers, and 3 replication. 10 into 3 into 3, 90 readings. Once you have 90 readings, you have to collect, you have to tabulate them. You have to tabulate them. First column, let's say, first column will be sample number. Sample number will be 1 to 10. Then second column will be appraiser. Then the third column will be the measured data. You understand, once you have 90 readings in 3 columns, your data is ready for analysis. Are you with me, all of you? Do you understand?
Yes, sir.
Yes, sir.
So
Yes,
in
sir.
another 2 minutes, I will produce a gauge order report, and then probably tomorrow we'll see how we can deep dive and then understand, right? So I am going to open a sample data for all of you, which will already have all these data arranged in this manner. So I am going to file. I'm going to open the worksheet. So this will open something like this. And you see there is an icon here. Something is written here. Look in Minitab sample data folder. There are thousands of sample data available here. So you need to click once. After clicking, you come here and then type AIAG. Sorry, not AAG. Type gauge. Gauge. When you type gauge, GAGE, the second file name, you see here gauge AIAG.mpw. You select that. It's an inbuilt data. I am opening. Once I open it, are you seeing the data here, all of you? And now
Yes.
let's see how much data is available. How much data is available?
Yes, 90.
90.
How many samples? 10 samples.
10
How many
samples.
appraisals?
10 samples.
ABC. And the readings, actual
ABC.
readings are recorded. Don't worry about the reading. Some reading. Maybe we don't know what reading it is. Some reading is available. Now we are going to analyze this. So go to stat. Go to quality tools. Go to stat. Go to quality tools. Come down to gauge study. Stat, quality tools, gauge study. And what kind of study is normally conducted in companies is crossed. I already told you what is nested. But assuming most of the situation, inside a company, it will be crossed only because they can share the instrument, share the parts, everything. So click crossed. Now this window will come. Once this window comes, you go to part number. Where is part number available? C1, right? Selected. Where is operator available? C2. Selected. Where is measured data available? C3. Now there are 2 methods. You can use any method. Don't worry about it. And you can use any method. And we'll only, read the report. Now gauge information. What kind of gauge it is? It's a vernier caliper, whatever it is. Date of study. Today's date, 9 May. Report. divided by 6 sigma bells, something. And what is the tolerance of this gauge, or some kind of, some tolerance is made available always. Because the tolerance, when it is available, see, what is the formula for gauge R&R? Precision divided by tolerance. So if you know tolerance, let's say plus or something, plus or minus 6. So the total is 12. Okay. Something I'm typing. Okay. And now option. Good option. The upper spec minus lower spec. Upper spec value minus lower spec value. So the total range is called what? Tolerance. This is what we declared as 12. You understand, all of you? 12. And then you click OK. And click one more OK. Now this graph will be populated automatically. Why this graph? This graph will help us to understand the root causes of the measurement error, whether it is repeatability error or reproducibility error, whether operator A is populating more error or B is populating more error, C is populating more error. Why the reproducibility error is so high? Who is not cooperating? Whether who is not coming in agreement? Whether A is not coming in agreement, B is not coming in agreements. Look here, look at the box plot and tell me, all of you. There is A, there is B, and there is C. And can you see the C's reading alone is pushed downwards? Can you see that? The box plot. So C all the time, C is pushing his reading downward. Can you see that?
Yes.
This is actually contributing to
Outperform.
reproducibility. So likewise, we will be reading this graph and we will be able to reach to the root cause of the measurement error. We will be able to control. Don't worry right now. Let us go to the session window. Come here. When you come to the session window, when you move from the bottom, there is a table. This is the table important to us first. No? This is the table, the first table. You see here, this one. See here, process tolerance 12, we declared. With respect to the tolerance of 12, the gauge R&R is how much? How much it is?
15.
15.12.
15.
You
More
have
than
to
process tolerance.
read the gauge R&R from here. Percentage tolerance. Study variation divided by percentage tolerance. Look here, 6 times standard deviation. Minitab also use the same formula to understand the spread. So 15.12 is the gauge R&R value. 15.12, what is the situation? Acceptable or unacceptable or conditionally acceptable?
Conditionally acceptable.
Conditionally acceptable.
This total gauge R&R is split into two parts. Repeatability 10, reproducibility 11. 10 and 11 together, how it is becoming 15? There is statistics behind, don't worry about it. Only look at the value, it won't tally. It won't tally. Repeatability and reproducibility will not tally to gauge R&R. That's a problem in working with standard deviation. But now tell me which is higher, repeatability is higher or reproducibility is higher?
Reproducibility.
So now you need to work towards reproducibility as well as control the repeatability, looking at the operator. And if you take some correct actions, the gauge R&R will fall below 10%. If it falls below 10%, then the measurement system will be acceptable. But in order to make it fall below 10%, you need to take right action. If you need to take right action, then you need to look at the graphs. Click the graph icon and open this gauge R&R and enlarge this and take a deeper look and try to understand each and every graph. And this is a bar chart. All of you, are you seeing bar chart here?
Yes, sir.
Yes.
There
Yes,
are
sir.
three
Yes,
different
sir.
yellow color, red color, blue color. Whenever you declare the tolerance during the study, you need to use yellow color only. I declare the tolerance, so I need to use yellow color only. So this is a visual understanding of total gauge R&R. This is repeatability, this is reproducibility, and this is the real process here, process variation. Now this is R chart. This R chart will help us to understand the repeatability error populated by each appraiser. Now look at the R chart of operator A. Also look at the R chart of operator B and C. Now tell me who is experiencing more error, more variation, A or B or C?
B.
B.
B. B is
B.
you see.
B.
So you can actually sit with operator B and you can actually give some additional training. Now repeatability error will start going down. Similarly for C, some of the parts, for example, part number 10, he is experiencing, more variation. But A seems to be, okay. But the problem I see is, all the readings are one side only, which is also against natural. Naturally, reading should go up as well as down. If the readings are always one side, that also needs to be looked at. So by deep diving into the graph, we can actually understand the root cause. But I will deep dive, make you also deep dive and slightly at a later stage. And this graph is called a box plot. This box plot is letting us clearly understand C is not coming in agreement with A and B. If all of them come in agreement, then reproducibility error will reduce. So by working with C, you can also improve what? Reproducibility. So how to make use of the remaining graphs and how to take the exact action we will discuss in the upcoming sessions. So do you understand, all of you? The gauge R&R study, how to conduct and how to interpret, very important, right? But don't try to do the calculations manually, and it's an outdated practice and not required as well. The logic is explained to you, but maybe if you really wanted to know even all the formulas and everything, probably at the higher level, if there is a real requirement, then we can talk about the formulas. But nowadays it's not required. And all of you, please note, you can use Minitab, or you can conduct the study, arrange the data as I told you in 3 columns. Copy the data, just put it in some AI tool. That will also give the similar results. So you try all those things, and we'll continue learning from here in the next class. Okay.
Okay, sir.
So we can
Yes,
wind
sir.
up now. So anything, any specific question anybody would like to ask? And tell me whether all of you are able to follow me. Straight away, I'm went to some depth in gauge order discussion. Still, is it followable? All of you are following me correctly?
Minitab is a
Yes,
part
sir.
of Excel, sir.
No, Minitab is
Data.
separate software. It's not Excel. Excel is separate. Minitab is separate. We will be
You have to
sharing
buy.
the link. The link is already shared in the group. Yes or no? Minitab link.
No,
No,
sir.
sir.
There in
No, sir.
No.
the
No, sir.
group description. Please, all of you go to the group
Not it, sir.
description. In the group description, Minitab installation link is there. You can copy, install, and you can also practice and add a line in your biodata that you have some proficiency in Minitab. It will add value, and or you can also directly download from internet and install. But it will only be a trial version, which will work only for 1 month time. So be aware of it and then use it.
Okay, sir. One
Okay.
thing you have told me is error 1, type 1 error, right, sir?
Type 1 error.
What is type 2?
Rejecting a You write the exam very well, but I still give you a fail mark. That's a type 1 error. I should not be doing
Okay.
it.
Okay.
Reject-
And what is type 2?
Yeah, type 2 error is, you don't write any exam well. Yeah, every question is wrong, but we still give you, very high marks. That's type 2 error. Now the society will face a lot of
Type 2 is better, sir. Then type 2 is better.
Yeah. But for manufacturer point of view, type 1 error is very critical. So we first control the type 1 error. And of course, that's why type 1 error is called manufacturer risk and type 2 error is called consumer risk. Why both are happening? Because of the measurement error. So industry standard AIAG guideline is type 1 error should be below 10%. That's called, that's the guideline, gauge or study. Both the type 2 also will experience the same. Okay, we'll continue discussing tomorrow. It's already 10:25. Thank you very much, all of you. I hope
Thank you,
you
sir.
all.
Good night, sir.
Yes, sir.
Thank
Thank you.
Okay, good night, sir.
Thank
Good
you,
night.
sir.
Good night.
Thank you, sir.
Good night, sir.
Yes,
Good
sir.
night.
Good night, sir.
Thank you.
Good night.
Thank you.
Good night, sir.
Right.